Determine an equation for the pictured graph. Write your answer in factored form and assume that the leading coefficient is either a positive one or a negative one. Before I give the formula and start explaining how all of this works, I would like to remind that the leading coefficient is actually determined by the end behavior of the graph. There are four options. Goes up on the left and goes up on the right. In this case, the leading coefficient is positive and the degree is even. It may be going down on the left and down on the right. In this case, the leading coefficient is negative. The degree is still even. It may go down on the left but up on the right. In this case, the leading coefficient is positive, but the degree is odd. Finally, it may go up on the left or down on the right. And in this case, the leading coefficient is negative and the degree is still odd. Clearly, our end behavior looks like the second option, down on the left and down on the right. So we know the leading coefficient will be a -1 since we are selecting between a positive or a -1. So it will be a -1 and the degree will be even. So now the formula that we will use to write the equation for this function. The formula is y equals the leading coefficient times x minus the first zero. I'm just going to say 0, 1 in parentheses, and the exponent of the parentheses will be multiplicity of the first zero. I'm just going to use m1. Then continuing x minus the second zero, multiplicity 2, x minus the third zero, multiplicity 3, and so on. If you have more zeros, you'll just continue with x minus 0, 4, multiplicity 4, and so on. So we already know the leading coefficient. We have that part for the formula. This here is going to be -1 based on the end behavior. Down on the right and down on the left. The next thing we'll determine is the first zero, the second zero, and then the third zero. Zeros are the points where the graph touches or crosses the x-axis. Looks like from left to right, the first point where the graph crosses the x-axis is -2, then we have a 0, and then we have a +1. So -2 will be our first zero, 0 will be our second zero, and +1 is our third zero. Now I need to determine the multiplicities for each zero. The multiplicity is determined by the behavior of the graph at each zero. If the graph crosses the x-axis at a particular point that we call a zero of the function, then the multiplicity is odd. So if it crosses, multiplicity is odd. If it touches, sometimes you may see terminology turns. If it turns, then the multiplicity is even. Most of the time, unless otherwise stated, the odd multiplicity will be a 1 and the even multiplicity will be a 2. Again, unless you are specifically told that the multiplicity for that 0 is something else other than 1 or 2. Okay, so we're going to look at the graph at our first 0, which is -2, and looks like the graph crosses the x-axis at that 0, so my multiplicity for that first 0 inside the formula will be 1. At 0, the graph turns or touches, so the multiplicity for that one will be 2. At the last one, the graph crosses again, goes from being above the x-axis to being below the x-axis, so that one will be a 1. I will now rewrite my formula with all of this information that I have. So here we go. I have y equals the -1 for my leading coefficient. In the first set of parentheses, I have x minus -2. Minus a negative will turn into a plus with the power of 1. The second one is x minus 0 with the power of 2. And the last one is x minus 1 with the power of 1 again. The last thing, I'm going to clean it up some more. So these exponents, 1 and 1, we don't have to write them. By default, if there is no exponent, it's considered a 1. And then here, minus 0 also doesn't have to be written because x minus 0 is just x. So here's the final version. Y equals a -1, or you can just keep it as negative without the 1, x plus 2, x squared, x minus 1. We're done.